Welcome back to the Chemistry Assistant channel. We are going to now dive right into balancing redox equations. Many of you were really confused, and so was I on Thursday when we were going over these. I think I found a better way and a more simplified way to explain these that actually makes sense. But before watching this video, make sure that you're really good on oxidation numbers. That is the key to doing these. We're going to dive right in though. So the first thing that you want to do is basically just go through and assign oxidation numbers. Just think of it bit by bit. So like we saw in the last video, copper here. So let's think about copper. What would copper's oxidation number here be? All by itself. Any element by itself automatically has an oxidation number of 0. Let's go on to HNO3. Well, the hydrogen here, we always know it has a +1 charge. Nitrogen here, well, we don't really know what that is yet. Oxygen. Well, each oxygen is -2, and we have 3 of them. So think of it as 2, here, -2, -2, and we have 3 of them. So that's -6. So we have a total of -6 charge. And we know each individual element will combine to create a 0 overall charge, unless it states otherwise. But in this case, it has a 0 overall charge. So how would we have to create that? Well, if nitrogen had a +5 charge, then 1 + 5 would be 6, and 6 minus 6 would be 0. Okay, great. Let's move on. Copper here. Let's see. Well, we don't in copper nitrate. Copper nitrate, sorry. We don't know what copper, or we don't know what nitrogen is by itself. We only know what oxygen is. But if we look here, this is the real key. That's 2 here. The 2 tells us that, since nitrate by itself has a -1 charge, that the copper here would have to have a +2 charge. Then that really helps us out. Because, here, I'm going to write this down here. Copper nitrate 2. So since we know this is +2, this oxygen, each oxygen by itself is -2. We have 3 of those inside the nitrate, and we have 2 more of that. So, -6 times another 2, it's a -12. So we've got our +2, -12, and the overall charge has to be 0. So that means the nitrogen here would have to be a +10. Okay, so let's go back to our full redox equation here, and let's see what it would have to be. So we already have what our copper is, we already have what our hydrogen, what our nitric acid would be. So this is +2, this is +10, sorry if that's kind of messy, and this would be a -12 overall, but individually that's +2, +5, and -2. So each individual, even though the overall charge in the nitrogen in the nitrate would be +10, each individual nitrogen would be +5. Let's go on to our next one here. And NO2, nitrogen, well, the oxygen, you always have to start with what you know. So each oxygen, as we said, -2, we have 2 of them, -4, the whole thing has to equal 0. So this side would have to be +4, okay? So we know each one here, so each nitrogen in nitrite would have to have a -4 charge. And each oxygen would have to be a +2. Then this one here, this one, just remember, H2O, just automatically go +1, -2. You can do the same thing with assigning the oxidation numbers and everything like that. What is the first step? Most people are just good up to this step, and that's how I was too. But, what do you do after this? Okay, so the first thing you're going to do is, what elements in this equation change? What changes? Well, let's just go one by one. So our copper here. Our copper goes from 0 to +2. So this one definitely has a change. Just going by changes, not which one goes under oxidation or which one goes under reduction. Let's just go to the basics first. Which one changes? Copper changes, right? Goes from 0 charge to a +2 charge. Cool. The next one here, I'm just going to simplify it quicker when you can do each one individually. Nitrogen here goes from a +5. It's a +5 in copper nitrate too, but it goes to a -4 over here. So that one undergoes a change as well. So these are our 2 big changes. Copper goes from 0 to +2, and nitrogen going from +5 to -4. Great. Where do I go from there? Now we just got to keep track of our electrons here. So now we're going to talk more about the oxidation and reduction. So copper is going from 0 to +2. Well, let's think about this for a second. This copper here on this side is a lot more positive than that copper on that side, right? So as a result, the copper is becoming more positive. So in order to balance these two out here, copper +2, you would have to add 2 electrons, because think about that. In order to get it to 0, this +2, which would mean we have an abundance of protons, but now it's going to be balanced out with these 2 electrons here, okay? And then for our other one here, for nitrogen +5, okay. Well, might as well state here that this one, as a result, is losing electrons, so it would be our Leo and the Leo-ger, the Leo, as everyone kind of remembers it that way, the Leo, so this one would have to be the oxidation. I'm just going to abbreviate it here. So, and this one here is gaining an electron. Oops, made a mistake. This is supposed to be +4. This one, as a result, would be the reduction. Okay? So, N with a +5 charge would be adding an electron to it, because think of it, think of it just this way. Simplify it down. +5 here, and then just think of it as -1 here. So 5 minus 1 is 4, right? So a lot easier to understand it that way than how we were really talking about it in class. So that's where we're at right now. How do we go from there? How do we go to this, balance? The whole goal of this is the balancing. How do we go from here to now the balancing of it? Okay, that's what we're really going to dive into now. Okay, so the next part of this is looking at making sure we have the same number of electrons in our oxidation reaction, so the copper here, and we have the same number of electrons that are being gained and lost, basically. Well, let's look at this. In our first one, we have 2 electrons that are in the product form, right? But this one here, we only have 1 electron here. So what do we have to do? Well, we're going to have to multiply this whole thing here on the bottom here by 2 in order to make this here 2 electrons, right? So now we've got 2 electrons here in the product, and we've got 2 electrons here. So let me just rewrite everything. So our copper with a 0 charge, nothing happens to it. We don't need to add any more electrons. We've already got our 2 electrons here. But in our nitrogen with our +5 charge, now is going to have here 2 electrons here, and 2 and +4. Okay, this realizing and balancing electrons here is the key to balancing the electrons. So let's explain how this translates to balancing it now. Let me just kind of rewrite everything. So as you see, what I did here is I took that 2 and I multiplied it by everything of all the compounds of the nitrogens that we use. So this was from our N5, I multiplied it by the 2 there. The 2 here from the N+4, okay? Let's kind of go over and just check, let's see if we're done. Well, let's see, we've got our copper here. We've got 1, right? So we're good on that. Copper, check. Good, check. Hydrogen here, we've got 2 here. Okay, let's just keep 2 there. And nitrogen, we have 2 there. Oxygen, we have 6, okay? Copper, we said we were good on, we had 1 and 1 connection there. Hydrogen, let's see how many we've got. We've just got 2, so we're good on our hydrogens. It looks like we're good on our hydrogens. Nitrogen, we have 4. Ooh, that's a problem. And oxygen, we have 3, but times 2 is 6. 6 plus 4 is 10. 10 plus 1 oxygen there is 11. So we have 11 oxygens. We are in quite a predicament here. Well, let's just test something out here. Let's just see what happens. What if we were to have 2 water molecules? Let's see how that changes everything. Well, instead of having 2 hydrogens, we would now have 4. Instead of having 11 oxygens, we would now have 12. Okay, that's good. But now we have twice as many hydrogens on this side and twice as many oxygens. Well, let's go back to this side. What if we were to just double this? So we get a 4. Well, now we'd have 4 hydrogens. Perfect. 4 nitrogens. 4 nitrogens like we have on the other side, and now we have 12 oxygens. So now we're all set. So this is our redox equation. So our final equation is copper plus 4HNO3 gives us copper nitrate 2 plus 2NO2. Sorry, I kind of ran out of room there. But plus 2H2O. That is our final balanced redox equation. I'm going to probably post 1 or 2 more examples on this to really make sure you guys are strong in this. But I'm hoping this maybe kind of clears up and is a lot more simplified way of doing it. Enjoy the rest of your day. This is Christopher Zeuthen, part of the Chemistry Assistance Club, signing off.